Wow, I like that. It got really quiet. All I had to do is walk on stage. I wish my kids behaved that well. Good evening, ladies and gentlemen, and welcome to beautiful Shryock Auditorium on the campus of Southern Illinois University, Carbondale, in the solar eclipse crossroads hub of the universe. We're awfully glad you're here. I'm Jeff Williams with WSIU Public Radio, and it's my honor to welcome you here on behalf of Southern Illinois University and the Planetary Society for this special edition of Planetary Radio Live. It's going to be a great evening. We have a fantastic show for you. Matt's got lined up. It's going to be a wonderful time. I do need to take care of a little bit of business and thank some of our sponsors that are making tonight possible, including Southern Illinois Healthcare, AES Solar, Adler Planetarium, Pepsi Mid-America, the Louisiana Space Consortium, Cristados and St. Nicholas Brewery. Thank you very much for your support. Thank you for being here this evening at this wonderful eclipse event that's going on right here at SIU. It is now my pleasure to introduce to you, from the Planetary Society, the host of Planetary Radio, ladies and gentlemen, Mat Kaplan.
Wow. Thank you, everybody. Welcome. Now, we're going to have a genuine showbiz start here in a moment, but I got a couple of things to mention to you as well. First of all, to tell you, and you'll hear me say it more than once, how incredibly thrilled I am to be out here with you for what is happening, not just tonight, but especially tomorrow. And I hope, I don't know, I could not really hear Jeff backstage, so I don't know if he asked this or not. How many of you are going to be at Saluki Stadium tomorrow? Cool. Yeah, you can leave those up for a moment, Seth. Wow, this is such a beautiful hall. It's just thrilling to be here to do the show. Okay, here are some more questions that I had, which you may already have been asked by Jeff. How many of you listen to WSIU? Tons. And how many are members? Not bad, not bad. It's a good percentage. The rest of you, you know what you're supposed to do. I got a special treat for those of you who are either WSIU members, not just listeners, but members, it's an honor system, or Planetary Radio listeners on WSIU or anywhere else you may hear the show. Who's a Planetary Radio listener? Not bad. Wow, thank you so much. That's fantastic. I won't have enough for everybody, but if you would like, a very rare and very valuable Planetary Radio sticker. I have a handful. Now, we're going to have 3 times during the show when you guys are going to get to participate. We're going to have a little audience Q&A at the end of the first panel, because we're going to have a science panel, everything helio, everything solar. And then we're going to hear from Jenny Johnson. The Jenny Johnson Band is going to join us. I'm not surprised. She's got fans here. They have so many gigs this weekend that they are literally coming direct from their last performance to join us on stage. So that's pretty exciting, and I'm told that they have a premiere, at least a performance premiere, of their Eclipse song for us. It's on her new album, but they have not performed it in public yet. So that you will be the first, we will all be the first to hear that actually performed on stage. So then we'll have a second panel, an outreach panel, and there'll be another audience Q&A. And there are some terrific SIU volunteers. We've got one for each aisle down here, and you guys up in the balcony, high up there, in the cheap seats. And there are some seats down here if you guys want to fill in, but there will be somebody up there with a wireless microphone as well. They will come around. If you raise your hand, they'll come around. They're very kind, and they'll take care of you. They will even hold the microphone for you. Don't try to wrestle it away from them. But they will hold the microphone. If you have a question, please make sure it's a question and not a statement about your alternate theory of relativity, because we get those in the mail a lot. Because we will have some people up here who could talk about relativity. One, in fact, will. Make it a quick question, and then we're going to try and move on, because we have very little time for the panel discussions and much less time for the audience Q&A. Then, we're going to do our What's Up segment, and now this one is iffy. Normally, as you Planetary Radio listeners know, I would be talking to Bruce Betts. He would be here on stage, but he is in Madras, Oregon, waiting for the eclipse. We were going to try and bring him in by Skype, but this beautiful old auditorium is basically pre-internet. And so we couldn't bring him in that way. We're going to try and get him on the phone, but it's quite possible that we won't even have the bandwidth for that. If we can't do that, then we're going to pause and we're going to do a plan B, because we have the Space Trivia Contest. So, look what I've got. Rubber asteroids. Some of you know about those and how rare they are. There are very few rubber asteroids anywhere in the solar system. And we have 4 to give away here. And those will be for whoever answers each of our trivia questions first, correctly and first. And for a grand prize winner, a Celestron solar telescope, just in time. So, only one, I'm afraid, courtesy of our friends at Celestron, who also have provided 8,000 pairs of eclipse viewing, not just glasses, I'm told, but binoculars. They're like cheap 2-power binoculars for our viewing of the eclipse tomorrow. And I hope everybody is hoping, praying, your choice for clear skies tomorrow. Okay, I think that's everything that we have to talk to now. I'm going to start the radio show. We're already streaming live, so hello to everyone who's out there watching us, either on the WSIU site or on planetary.org. But this is going to be turned into an episode of Planetary Radio as well. So we're going to start this for the radio show, and we'll do that now, and then we'll start bringing people out. So please feel free to react. Make it as big and loud as you like. Oh, and I left out also, you're going to have a chance to yell out random space fact, but we'll get to that too. So stand by. Here we go, everybody. And I assume the recorder is running, because I forgot to give you guys my digital recorder. So I assume that I'll be able to get audio from you later. Here goes. Stand by. Whoop, we'll wait for that to go away. Was not the sun. Now we'll go. Stand by. This is Planetary Radio Live. Good evening, Salukis. We're coming to you from Shryock Auditorium, I've learned to say it, on the beautiful campus of Southern Illinois University, Carbondale, smack dab in the middle of the path of totality for the Great American Eclipse. I'm Mat Kaplan of the Planetary Society, proud to be here and thrilled to serve as SIU's Master of Ceremonies for tomorrow's celebration of the eclipse. How many of you will be outside tomorrow waiting for the shadow of the moon? Wait a minute, there's one guy over here who's going to be hiding in a closet? That's just crazy. Wherever you're going to be on Eclipse Eve, we hope that the next couple of hours that we're going to spend here at Shryock will help you build the sense of anticipation and excitement that we have about tomorrow's cosmic event. And you've heard that enthusiasm from this crowd that is going to be in the middle of the path of totality. I want to say we have one of the best Planetary Radio Live panels ever, but that would be a lie because we've actually got 2. And you'll hear our musical guests for this evening. They are Carbondale's own Jenny Johnson Band. There is one more person who wants to welcome you tonight. Oh, and to do this, I've got to be ready to change slides. Did we lose our slides? Okay, we'll cut this out. You guys get to see behind the scenes. No, we're still there. Sorry about that. I hadn't touched the laptop in a while. I got to back up. We should start that fresh. Okay, give us that reaction again, and you guys will hear this on the streaming audience, but the radio audience won't. So pity them. All right. There's one more person who wants to welcome you tonight. Here's a message from my boss at the Planetary Society. I think a few of you may recognize him.
Fellow Eclipse Chasers, Bill Nye here, CEO of the Planetary Society. I'm sorry I won't be in Beatrice, Nebraska, about 500 nautical miles north and west of you, also experiencing totality tomorrow. It's exciting, it's awe-inspiring. It celebrates our understanding of the motion of the planets and moons and our understanding of the cosmos and our place in space. This is a remarkable thing to experience. So have a good conversation tonight, and we'll see each other tomorrow in the dark. Except we won't see each other, it'll be dark. How cool is this? Back to you, Matt.
Thank you, Bill. He's a good guy to work for. That's Bill Nye, the science guy, the CEO of the Planetary Society. Take a look at this amazing montage of images. And this one of the sun's beautiful corona, which if we get those clear skies and a little bit of luck, we're going to be able to catch tomorrow. These views are largely why we and millions like us have gathered in this, narrow band stretching from Oregon to South Carolina, the path of totality. We're going to meet the astrophotographer who took these images in the second half of our program. Our first group of panelists, though, is here to help us appreciate the truly awesome science behind this and all eclipses and much more as we talk about our sun, our own local star, and a little bit about other stars around our galaxy and the universe. We're going to learn a lot about why those stars play a literally central role in life on Earth, our star, the sun, while we might even make a few gravity waves. So we're going to start with our first guest, who is the director of and let me stop for a moment. We're still getting a little bit of feedback from the monitor up here. I thought I'd better mention just in case it's getting into the recording. Yep, still got a touch. Okay. Our first guest is the director of the Heliophysics Division in the Science Mission Directorate at NASA headquarters in Washington, D.C. That puts Stephen Clarke in charge of the Space Agency's National Research Program regarding our sun. The program ranges from research grants to exciting missions like one we'll hear about that will head for our star next year. Steve has been with NASA for 17 years with deep involvement in many missions and a long history at the Kennedy Space Center before coming to headquarters. Among his many awards is NASA's Exceptional Achievement Medal. Please help me welcome Steve Clarke. Hey, Steve. Have a seat. Lucianne Walkowicz was just named the Baruch S. Bloomberg Chair in Astrobiology at the Library of Congress. You might wonder why somebody who studies the magnetic fields of our sun and other stars is working in astrobiology as well. That's till you remember that the sun is responsible for all life on Earth and for the existence of Earth itself. Those magnetic fields can still have a profound effect on humanity and on civilization, which is also something Steve is going to be able to talk about. Lucianne is also an astronomer at the famed Adler Planetarium on the shore of Lake Michigan. Her diverse expertise includes the ethics of Mars exploration and how to use advanced computing to discover unusual events in large astronomical data sets. Walkowicz is a TED Senior Fellow and a practicing artist working in everything from oil paint to sound, as you will literally hear in a few minutes. Please welcome Lucianne. Here's a space trivia question for you. What was the first spacecraft to set down softly on any other body in the solar system? That's not one that'll get you a rubber asteroid, but I'll tell you the answer. It was the Soviet Luna 9 spacecraft in February of 1966, followed just 5 months later by the first of 7 surveyor landers sent to the moon by the United States in preparation for the landing of humans, the Apollo landings. Our next guest was part of that survey half a century ago, and he has been building instruments for planetary science probes ever since. Far more missions that we have time to mention, but they include the Mars Exploration Rover, Spirit and Opportunity, the Cassini mission that is about to end after 12 glorious years orbiting Saturn, and the European Space Agency's equally successful Rosetta mission to Comet 67P. Thanasis Economou is now a senior scientist at the University of Chicago's Enrico Fermi Institute. I am honored to welcome Thanasis, or Tom Economou. Come on out, Tom. Nergis Malvalvala. Oh, I messed it. I practiced this endlessly. I'm going to try it again. Nergis Malvalvala. It has only been a year and a half since the entire world went wild over the announcement that gravity waves had finally been detected. One of the leaders of that effort, Kip Thorne, has joined us on Planetary Radio several times. Some of you may have heard him. Tonight, we welcome another member of the LIGO team. LIGO, that's Laser Interferometer Gravitational Wave Observatory. It is one of the greatest scientific and technological achievements in history. Absolutely no doubt. I've got to get this right. We need to do her justice. Nergis Malvalvala is Marble Professor of Astrophysics at MIT and part of that school's LIGO group. It's not an exaggeration to say that her pioneering work on the LIGO detectors gave them the absolutely exquisite, jaw-dropping precision that was needed to detect the infinitesimal changes in space itself caused by gravitational waves generated nearly 1.5 billion years ago, and of course 1.5 billion light years away. She received a MacArthur Genius Grant in 2010. We'll soon find out how all of this is related to solar eclipses. Please welcome our fourth and final panelist, Nergis Malvalvala. Thank you, Nergis.
Thank you.
Now, before we go on, I think I need to mention that two of our distinguished panelists were not born in this country. They chose to become Americans, and I think we should all be very grateful that we did. That's them on the end. Steve Clarke, you brought along this beautiful Eclipse Animation, NASA animation. Tell us about it as we watch it. It's getting started right now, and I'm afraid you'll have to see it back there.
Okay. Hopefully everybody can hear me well. So this is simulating what everyone will see on Monday. You can see the moon is between the sun and the earth, and you'll see two shaded areas. One light shaded area is called the penumbra, which is where the partial eclipse will be seen across the United States. And then you see the darker region, which is the umbra. That is the direct line between the sun, the moon, and the earth, and that's the path of totality as it moves off the coast of the United States. It'll take approximately about 4 hours to traverse the contiguous United States, and that's the total part of the eclipse. The totality will take about an hour and a half, and it moves roughly at about 1,800 miles per hour across the country, so that's why it goes so quickly across the continental U.S.
Amazing. Lucianne, it's only recently that we've been able to use spacecraft, the spacecraft that Steve's division helps to manage, to reveal the sun. It really is never before. You've brought two videos that are guaranteed to drop jaws. Let's take a look at the first one and tell us about this.
Sure.
Yeah, get right in there close.
Yeah. So this is a wonderful video that was created by the Solar Dynamics Observatory, or SDO. And I'm not ashamed to say that they have a wonderful YouTube channel, and you should all watch it all the time, and I definitely do that. What you're seeing here is the sun in all of its changeable glory. So all of those loops and bright spots and dark regions that you see over the surface of our star are caused by its magnetic field. And these changeable regions help us understand how it affects us here on Earth and can even impact things like our technology and our power grid.
So we got another one, and it is equally amazing, equally spectacular. And this one has a little audio that we're going to keep low so that you can tell us about what we're going to be seeing here. There's some real nice music under this.
Sure. Many of the loopy structures that you saw in the previous video were the magnetic field as it loops and becomes tangled in the outer atmosphere of our star. And it traps this hot material from the sun, but like an elastic band, those loops have some tension in them, and that tension can cause them to snap and rearrange. And when that happens, it creates what we call solar flares and sometimes also CMEs, or coronal mass ejections. And this is when you have this trapped material flung deeply out into space where it can sometimes impact the Earth. Some of the time this creates things that are very benign and beautiful, like the northern lights or southern lights, and sometimes it creates things like blackouts or interruptions in our power grid. But we study these to understand how stars influence the habitability of planets or their suitability as a host for life. And really everything we know about those other stars, we learn from the sun.
And I think it's already... what you're seeing in just that flare, that on the of the sun.
Aren't you glad you're 94 million miles away?
Yes, at least. Sometimes I wish I was further, like the heat out there today here in Carbondale. We talked about, I mentioned up front, why what happens on the sun can still have a huge effect, other than sustaining life here, what it can mean for civilization here on this planet. And I know something that happened in the 19th century that you and I talked about, Lucianne, that it's a good thing it happened when the only electronics out there, the internet was the telegraph at the time.
Absolutely. The Carrington Event, which happened in 1859, was the largest space weather event recorded in history, and it impacted our Earth by creating not only auroras that went down not in the northern hemisphere like we usually think of them as being up by the poles, but all the way down to the equator, even visible so brightly at night that some people got up, thought that it was they were camping and they thought it was dawn. And at the time that created currents in the telegraph, which was the dominant technology. But today we study the sun in part because we want to be able to predict when events like that might happen, because we're a much more technologically dependent society now.
Steve, if we had something like the Carrington Event now, how devastating might that be?
Well, it does have the potential to knock out certainly the power grids. Although the electric companies have been working very closely with the government to try to prevent those type of things, to basically engineer out those type of events. But it can interrupt navigation, particularly of aircraft. The Federal Aviation Administration would have to reroute airplanes from around the poles instead of going over the poles. It interrupts communication. It could certainly, we all rely on our smartphones for Google Maps or Waze. It could certainly interrupt the GPS signals that give us all of that information. Mentioned how dependent we are on technology today. So an event like that, similar to the Carrington event, certainly could have much wider impacts to us today.
We could spend the entire time we've got here this evening talking about the sun, but there is a body that tends to be forgotten when we talk about total solar eclipses. It's this one. And it plays a pretty important role, since it is, after all, only because the moon is going to pass in exactly the right spot tomorrow that we are going to get the treat, for some of us, of a lifetime, a total solar eclipse. Tom, I want to go to you to talk about this. You worked on one of the first programs to explore the moon. In fact, only the second spacecraft, as we said, to soft land on the moon was Surveyor. The image that we've got here shows us one of those spacecraft. Were you in on that right from the start?
Yes, I was.
Pull right in there. You could talk right next to that.
Yes, I was part of the Surveyor missions. I came to this country in 1964 and was lucky enough to get involved with the exploration of the lunar surface to get in preparation for the Apollo missions. we don't realize, but at that time we knew very little about the moon. Sure enough, moon was not made of green cheese that we know at that time. So NASA asked us to design and construct an instrument to get the chemical analysis of the moon in order to provide some meaningful information for the next mission to bring the first Americans to the surface of the moon.
Wasn't there concern before the Surveyor spacecraft and the Soviet spacecraft, the Luna, started to go there, that we knew so little about the moon, we didn't know whether you could land on the moon without just sinking into the dust?
Oh yes, this was a big question actually. At the last moment they made us put something like a snowshoe on our instrument to prevent from sinking on the lunar soil. From these 7 Surveyor missions, we got enough information that enabled us for the next stage for the Apollo program.
And I'm going to pause for a second because we're still getting some feedback, at least from this monitor. And, you know, if you need to, you can take that down some, guys. I want to go to another image because we don't want to forget that eclipses of one kind or another can happen anywhere. You have 3 bodies and one of those gets between the other 2. This, in a sense, is an eclipse, right? Because we've got Saturn backlit by the sun, and this is taken by Cassini, right?
Well, I'm also involved in Cassini, but with an instrument that counts the number of particles in the rings. Saturn is a very interesting planet with many rings that are composed mostly with very fine particles, mostly ice and some dust particles. The interesting thing is that the diameter of these rings are hundreds of thousands of miles, where the width is only a few hundred feet. You know, that's very interesting and very
amazing.
Peculiar.
We're going to move on to, speaking of dust particles, another mission that you were part of. Here you are at JPL in the master control area there, where so many missions have been controlled. What mission are we looking at here?
This is a mission to an asteroid, Will 2. It was launched in 2009. It took almost 10 years to get to the asteroid, and it went through the coma and detected, or our instrument measured the number of particles within the coma and the size of these particles. We learned lots of information from these missions, and actually Stardust was so healthy that we used it, the same experiment, to send it to another asteroid 5 years later. So with one spacecraft, actually we achieved the results for 2 missions.
And here is the dust collector from that mission, from Stardust, that is.
One of the results of this Stardust mission was it went through the coma and collected the dust particles, brought it back to Earth, and we distributed these dust particles to the best laboratories here on Earth to get analyzed, to find out what they are made of, in order to understand the origin of these bodies.
And so here we see, embedded in aerogel, this incredibly light material, are actual particles. And my point here really that we're getting to is, we think of space as an empty vacuum. It's not. We have stuff like this. and more that we'll be talking about.
Well, in order to collect these particles, we use a special catcher, which is called aerogel, that's enables us to embed these particles without destroying them, and so we can analyze it here on Earth. And you are right, space is not empty. Besides having all these planets and planetary bodies, there are lots of these tiny dust particles or large bodies, meters or hundreds of meters, kilometers, that constantly bombard the Earth every second.
And there's more than dust and gas, as our physicists on the panel certainly are aware. With that in mind, but with a little bit of a preview looking back in history, Nergis, I want to go to you because these are actual clippings and records of something that was pretty historic, almost exactly 100 years ago. Tell us about what we're looking at.
So thank you, Matt. So what we see here are a couple of images from the eclipse of 1919. Now, what had happened in preceding years, starting in 1915, was Einstein had erupted on the scene and had kind of turned our ideas about gravity on their head. And one of the predictions of his theory of general relativity, which was a theory of gravity that's different than Newton's, was that light should bend around gravitational objects. Now, something that's not well known to most people is that Newton had predicted something similar, but with a factor of 2 less than what Einstein's prediction would be. So the idea is that if you have a star behind the sun, then the light from that star will bend as it goes around the sun, and it'll bend towards us on the Earth, and we would be able to see a star in a different position, in an apparent position. Even though it's behind the sun, it would skirt the edge of the sun.
And this is why, prior to general theory of relativity and Eddington, there were a lot of people who thought, gee, Mercury is not exactly where it should be. There must be another planet there called Vulcan. It wasn't, right? It was relativity.
That's right. General relativity had many successes, but I want to go ahead and say that when so Einstein made this prediction, Eddington, who was a well-known astronomer in England at the time, understood that this eclipse was coming up, and this was a total solar eclipse like the one we're about to witness. And it happened to line up with a group of stars that would be ordinarily behind the sun, but because of the bending of light, they would skirt the edge of the sun. And if you could remove that bright disk of sunlight, which the moon gladly does for us during an eclipse, then maybe you could catch those stars in a slightly different position. And so Eddington launched an expedition to 2 sites. So this was a total eclipse, much like the one that's going from Oregon to South Carolina here. He caught it at 2 different places, one on the west coast of Africa and the other in the northern Brazil. So he had 2 teams of observers. He was in West Africa, and he had a colleague in Brazil. And they made a measurement where they actually were able to show that their measurements were closer to Einstein's prediction than to Newton's. And there was a factor of 2 difference, and his measurements were closer to Einstein's. And remarkably, for a sort of variety of historical and sort of geopolitical reasons, this was the measurement that catapulted Einstein into becoming a household name. It was sort of Einstein had introduced general relativity in wartime Germany, etc. And then this measurement that was done post-war, and this became he became a household name then.
So anything really big, everything with any mass bends space. Stars are really big, they bend it more. But they don't just bend space, there are other effects, which is what you were looking for.
Yeah, so, I do have to say, so Tom's work reminds us that space is not empty. I want to say space is not only not empty, it actually is a very, very active and violent place. And in fact, it has a life of its own. Space can bend, as Einstein told us. This was the way in which Einstein's ideas of gravity were different than Newton's. Einstein said, we experience gravity because massive objects curve the space around us. So space can curve. And then also out of Einstein's theory of of general relativity came this added piece, which may indeed have been the most outrageous piece of Einstein's general relativity, was that space can also ripple. And in fact, so we think of this idea of space around the sun bends, as in that little graphic there, but indeed, space can ripple. If the objects in space that bend space are actually whipping around each other or moving or accelerating, these ripples of space-time can propagate outwards, just as if we would drop a rock on the surface of a still pond, and ripples would emanate outwards. And then remarkably, also in Einstein's theory, it turns out that we as distant observers could actually measure these ripples if we were sensitive enough.
And so we get finally to our current day and the development of LIGO.
LIGO, the Laser Interferometer Gravitational Wave Observatory. So LIGO are these 4-kilometer-long L-shaped instruments that are interferometers, and the little animation on the top shows that as the lengths of the two parts of the L of the interferometer get longer and shorter, more or less light leaks out onto the detector at the bottom of that L. And what happens is, as a gravitational wave comes by, it moves the mirrors of LIGO by a ridiculously tiny amount. And let me tell you how ridiculously tiny. If you get gravitational waves from neutron stars, which are kind of cousins of black holes, from a nearby galaxy not too far from our own, those mirrors would move by less than 1,000th the size of a single proton. Okay. And indeed, so it sounds ridiculously small, and it is, but these large instruments could measure those. And you actually, if anyone wants to build one of these in their own garage or basement, here's how you do it. So you have two things you need to do. So the first thing you need is you need mirrors that are very, very still. And so you have to make mirrors on a whole lot of vibration isolation systems, like the ones that we show here, very much like the shock absorbers in your car. You know, you just put some springs and masses and you isolate them, but a little bit more sophisticated. You also take mirrors and you can hang them from pendulums or bungee cords. That also helps isolate them. And then finally, you've succeeded. You've made these mirrors very still. They're so still that the only thing that will move them is the passing gravitational wave. The vibrations of the Earth have been filtered out by these systems, but that would do you no good if you don't know how to measure a distance that's 1,000th the size of a proton. And you couldn't do that with a ruler, but there comes our laser light. So the laser is actually our meter stick, and that interferometer uses the laser as a meter stick to make these tiny measurements. And this whole effort has been funded for the last 40 years, since its inception with Kip Thorne and Ray, who Matt mentioned, and Ray Weiss, by the National Science Foundation in the US. And these were the instruments that made the discoveries that some of you heard about last year.
And so, rotating neutron stars, rotating about each other, rotating black holes, formerly stars not so different from our own.
Yes, indeed. And so, essentially, when one thinks about a black hole or a neutron star, which I already said are cousins of each other, they're stars like our own sun that have essentially come to the end of their lifetime because they've run out of nuclear fuel, and they collapse. And when they collapse, they form extremely compact stars. So a neutron star is a very nice example. It's a star that has the mass of our sun, but it has a radius of 10 kilometers. I believe that's the size of Carbondale. So
that's right.
So, and so you take a pair of neutron stars or black holes who are just slightly heavier cousins. Those can be 10 or 20 or 30 solar masses, up to much more, but in this class of stars that we look at. And you can have them whipping around each other in a binary. We all know many stars occur in binaries, and so neutron stars and black holes can too. And when they do that, they essentially disturb the whole space-time around them, and then those ripples of space-time travel towards us, and these instruments are capable of measuring those.
Let's see the actual result. This is it, right? This was the first actual detection?
This was it. This is the iconic data from the two detectors of LIGO. LIGO has two detectors, one in Washington, Hanford, Washington, and one in Livingston, Louisiana. And essentially, if you take away nothing else from these bumps and wiggles, the thing to look at is at the maximum of the peaks, which was when the two black holes collided, the mirrors were moving by 10 to the minus 18 meters. So the thousandth of a proton that I promised, there it is. And what did we learn from these bumps and wiggles? This is another amazing thing. Einstein had a lot of ambivalence about gravitational waves, about black holes, but his equations contained all the information. And what we learned from these bumps and wiggles, which you can then model with his equations, was that you had two black holes, 30 times the mass of our sun, and at the moment that they collided, they were whipping around each other at half the speed of light. So everybody has to sort of hold on to their seats here, right? Because this is sort of, if we were writing fiction, we wouldn't dare come up with this, right? And this particular system was 1.3 billion light years away, and there's another very amazing thing you can learn from this data, which is that when these two black holes collided, they formed a bigger black hole, but the bigger black hole was not as heavy as the two that it was made of, and 3 times the mass of our sun was radiated away as gravitational waves in these quarters of a second.
It's conservation of energy and matter. Still works, even at this scale.
Yeah.
I think it was Eddington himself who, I'm not sure of this, had that quote, that the universe is not only stranger than we imagine, but stranger than we can imagine, until we start to look and find these amazing things going on. Very, very briefly now, this is sort of LIGO to come, right?
This is a global network. So the two U.S. detectors are LIGO, shown on the top left. And then there's a whole network of detectors, especially the European detector Virgo that just came on the air earlier this month. And and a number of others that are planned in construction phase. And so I expect this to be sort of an explosion of detectors in the future.
And in a sense, we're at the dawn of a new age of astronomy, right?
That's what we think is going to happen.
Yeah.
So.
I don't know, Lucianne, this has to be exciting for someone like you, even though you deal with magnetic fields, the ability to do astronomy, to look out at our universe in a way that doesn't involve looking at light?
Absolutely. I actually stayed home and watched the press conference, like excitedly having my breakfast and coffee. See, it's still so exciting. I think this was incredibly exciting for essentially anyone who follows science. It really is, a lot of people use this phrase like, it opens a new window onto the universe. Like many, many press releases must contain that phrase. This actually opens a new window onto the universe. It's a fundamentally different way of studying, particularly the dark universe. And Nergis, correct me if I'm wrong here, but one of the significant things about this is that this was fundamentally the first direct detection of black holes.
Yes, so the thing that part of the excitement was that we had never ever seen black holes in this dance around each other and colliding. And those bumps and wiggles of the signal, that is what they're telling us. They are telling us we are two black holes that are about to collide with each other.
And Einstein didn't even believe they were real, did he?
Initially, no. He resisted it for a long time. But
amazing.
Here they are.
We're going to keep going. A lot of what we're learning, in fact, some gravity wave research starting to be done space-based. There was the LISA Pathfinder mission with involvement from NASA, I believe, but primarily European Space Agency, Steve.
Correct.
But here is an entire constellation of spacecraft studying our star. Tell us about some of what's happening out there, what NASA's doing with all these.
Well, so this graphic actually shows which spacecraft and we have aircraft looking at the eclipse Monday. We have quite a fleet that will be doing that job, taking data during the entire time of the eclipse. And so we're using every asset that we have available to us to gain as much data as we can to better understand. We're looking mainly at the corona, which is the upper atmosphere of the sun. When the moon blocks out the bright spot, the sun, in totality, what we can finally see clearly is the corona. And we're still unlocking mysteries of the corona. The corona is the upper atmosphere of the sun, yet it's millions of degrees hotter than the surface of the sun. And we're still trying to understand why is that? What are the processes within the sun that is creating that much of a difference in the temperature. We talked a little bit about solar flares and coronal mass ejections. We're trying to better understand how these form and better predict when they're going to come off the sun. We talked about space is not empty. We've talked about folds and curves, but it's filled with high energetic particles at all times. The sun is constantly throwing off high energy material, and this is what we call the solar wind. And the solar wind was actually theorized by Dr. Eugene Parker in 1958. And at first, when he had the peer review of that, nobody really supported that theory. And then as time has gone on, as that technology improved, we found, yes, actually with instruments, we have been able to determine there is constant solar wind in the solar system. And at times, there are some violent storms that are cast off the sun, sometimes towards Earth. We talked about what it could do to affect life here on Earth. But it also goes out in all directions. We've been studying how those type of coronal mass ejections have been affecting Mars, for instance. We look at our neighbor and we're trying to understand, why is it the way it is? Why is it so barren? Because we feel fairly certain that at one time Mars had water. It had an atmosphere. The difference between Mars and Earth is Mars does not have a magnetic field. We have a magnetic field, a magnetopause, that actually protects us from the most severe effects of those solar storms.
It's basically a force field.
It's basically a shield. And it does, those storms do interact with our own magnetic field, and that's why we see the northern lights. That's why we have some interruptions. And with Mars, since it does not have that shield, there is some theories out there that these coronal mass ejections have been stripping away the Mars atmosphere for centuries, and that's why Mars has become a barren planet.
And haven't we now confirmed that with the data from the MAVEN spacecraft?
Correct. That's where we've gotten just an enormous amount of data to support that theory, actually.
Tom?
Well, yes, indeed. Right now, we have on the surface of Mars two operational spacecraft, the Opportunity and the Curiosity. Opportunity is a very interesting mission. It was launched in 2003, and it was designed to operate on the surface of Mars for 3 months. We are now on the 13th year, and the Opportunity is healthy and willing to work additional, I don't know how many years.
The cliche joke is, if only our cars outlasted their warranty by that much.
But they are still functioning rovers and provide a good science. So we have a promise from NASA, so as long as we will keep our health, they will be supporting us.
Absolutely. Well, let's hope so. And then, of course, the next rover, if everything goes well, 2020, the 2020 rover doesn't have a nicer name yet, probably because the Planetary Society hasn't helped NASA pick one, let kids pick one. But we're looking forward to that, and maybe looking for the signs of past life on Mars before the sun blew off its atmosphere, because it had no magnetic field to protect it. You mentioned this fellow Parker, and he gets a nice tribute beginning, what, next year?
Yes. Actually, this is the Parker Solar Probe that is being built right as we speak by the Johns Hopkins University Applied Physics Lab in Maryland. And we're scheduled to launch this spacecraft July 31st of next year. And this spacecraft will fly the closest to the sun than we ever have before. In fact, 6 months after launch, it will be the closest we've approached it. But we won't stop there. We're going to do 7 gravity assists. And what I mean by that is it's going to fly around Venus 7 different times. And each time it's going to use the gravity field of Venus to adjust its orbit and put it closer to the sun each time. And we have a host of instruments on this. We're actually going to fly into the very upper regions of the corona that I mentioned earlier. This will be the first time we've actually taken data there instead of remotely from back, millions of miles back or here on Earth. We're actually going to be sampling that corona for the first time. So it's an incredible spacecraft, and we just recently renamed it in May for Dr. Parker. We had a big event, University of Chicago, earlier this year.
Were you there, Tom?
Yes.
I'm proud that Eugene Parker is a very known solar physicist that came out with this idea of solar wind, and I'm proud of his colleague from the University of Chicago.
Why not?
And it is for the first time that NASA has decided to name a spacecraft after a living scientist.
Lucianne, you're going to get the last word for this panel in a moment, but before that, as someone who has spent a good part of your life studying our star and others, it's got to be an exciting time to be around, to be able to do research like this with tools like that.
Absolutely. I really would love to emphasize how important these studies of the sun are, not only for understanding our own sun-Earth system, but also for our search for life in the universe. I worked for many years on NASA's Kepler mission, and with Kepler, we look for planets, and in fact, it's found thousands of planets now, and has told us that Earth, at least as far as being a small rocky world, is not alone. And the thing that we get with Kepler is the ability to study some of these solar flares just as changes in brightness of the star. But the sun is the only star for which we can get these kinds of high-resolution images that really tell us in detail what's going on. And so being able to study solar physics really tells us a lot about the stars that we find out in the universe that host planets. And that's leading us down to possibly eventually discovering life on one of those worlds.
Yes. All right, I'm going to save that last little treat of yours, which I'm glad you mentioned Kepler because it's related to that. Before we do that and close out this panel, and we are running late, how can you rush people like this? It's just, it's too wonderful. Let's bring up the house lights and go to a very limited number of questions from our audience. If you have a question, you can raise your hand now. And of course, this can be for any of our panelists or all of our panelists. And the folks out there here at Shryock Auditorium will bring a microphone over to you. There's one dead center in the middle there, I see, that is going to be hard to get to. Sir, why don't you see if you can work your way out? And yeah, but we need it for the radio, I'm afraid. So if you folks can let him go by. And this is another place where the radio audience probably won't hear all this. Hi, go ahead.
Most things that travel around the Earth have a decaying orbit. The moon is different. Why?
Who wants to tackle that? Tom?
Well, we are studying the moon for centuries now, but we still don't know exactly its origin. It's believed that it was created with some large collision between Earth and this special body, and that created the moon.
Lucianne?
Well, the interesting thing about the solar system is mostly the sun. Like, gravitationally speaking, the solar system is basically just the sun and like a little bit of Jupiter. So one of the cool things about the eclipse that you're going to see on Monday is that, you mentioned other spacecraft needing gravitational boosts to keep themselves in orbit. In the case of our moon actually also feels the tug of the sun, and so it's moving ever so slowly away from Earth. So we happen to live at a coincidental moment where the apparent size of the moon and the sun are the same in the sky, and we can have these wonderful total solar eclipses. And the reason we know this is, and this is like not an exaggeration, we bounce a laser off the moon.
And that was an Apollo experiment, I think, right? They left a reflector,
yes.
Tom? Yeah?
Yes, the first Apollo missions, they left reflecting mirrors on the surface of the moon, and we were able to use the radar for bouncing the signal from the moon.
So be glad you live in this Goldilocks era, because, a few million years from now, our descendants are not going to get to see a total solar eclipse. So too bad for them. Any other questions in the audience? How about, there's somebody way up there in the balcony. Can we get a microphone over to her? Hi.
Hi, I'm not going to touch the microphone. I was just curious, you've all said that there's going to be such a wealth of information tomorrow and there's so much you don't know about the corona. What is each of you, Matt, you included, what are each of you most excited to see or hopeful to see that you haven't seen before?
Is that out of the eclipse or just mysteries that remain about our star and other stars?
Answer how you will.
Okay, Lucianne, let's start with you. What do you hope to find out?
I mean, first of all, I'm just excited to see a total eclipse because I've never seen one before, and even as a scientist, like, that's just as exciting to me as it is to you. So the other part of it that I really think is interesting is that studying the lower part of the corona, the part that's really, really close to the sun, is very difficult to do. We build instruments that do block out that bright disk of the sun so that we can see the corona, but a lot of times it's really hard for us to get very close to the surface of the star. And the moon allows us to do that because it's nice and out in space and actually gives us a nice, very perfect blockage of the sun. And so that's an opportunity that doesn't come along very often.
Tom?
Well, there are so many mysteries about the sun that we don't know yet. For example, we know that the temperature inside in the nucleus of the sun is so high, millions of degrees centigrade. It comes from the decay of nuclear elements and the fusion and burning of hydrogen and helium. But the temperature of the surface of the sun is about 6,000 degrees, where the temperature of the corona is about 1.5 million to 2 million degrees, depending on the cycle of the 11-year cycle of the sun. Now, there are some theories or ideas how to explain this difference that the sun, which is only 6,000 degrees, can warm the corona to millions of degrees. And in building these models, we need a large amount of data. So that's why we take every opportunity during the solar eclipses to collect this data and build these models and eliminate hypotheses. What I am, in addition to my space exploration involvement, I am a hobbyist in designing instruments, and I collaborate with a team from Greece to build special spectrographs that measure the temperature of the corona. We take the spectra, and depending on the ratio of iron 15 to iron 10, we can then detect or calculate the temperature of the corona. And this depends on which phase the solar cycle is.
And is there a chance that, I mean, it's a counterintuitive thing, right? Why would the atmosphere of the sun, far from the surface, be so many times hotter than the surface itself? Is this something that maybe the Parker Solar Probe may, if you'll pardon the expression, throw some light on?
Ooh, I can't top that. No, actually, yes, that is one of the key objectives of that mission, is because we're actually going to be flying through the very top of the corona and sampling it. We're going to hopefully get data that'll start unlocking that mystery of how the heat is transported up from the surface and increased up through the magnetic field lines into the upper atmosphere. So we're looking forward to definitely doing that with Solar Probe.
Ernest, did you want to make a comment?
Yes, I just wanted to go back to the question of the eclipse tomorrow, and I wanted to take a slightly historical view, coming back to, say, the Eddington experiment, which people may not know had a lot of controversy around it. It was not clear that the measurement was as tight as the Eddington team claimed to be. It turns out, looking back at it, it was a good result, but that measurement has been done for eclipses ever since, and continues to be done. And we get better and better limits on that. And that's a very important thing to do, because between Newton's prediction and Einstein's, there was a factor of 2. Now, it could be that Einstein isn't the final word on how gravity behaves, and if you could get a more precise measurement, you might start to poke holes in Einstein. And so it's very important to keep doing. And so that's one of the things that I think I can look forward to.
Steve, very briefly.
I'd like to echo what my colleagues said of what we'd like to see, and I too have never seen an eclipse firsthand, so I'm looking forward to that.
Wow, all kinds of newbies up here, including me.
And beyond the research that I hope this really brings about from all of the data that we see, there's one other part of this, is the public engagement in this. We have citizen science going on all across the country. Yeah, I agree. And I truly hope this inspires a whole new generation of future scientists and engineers to want to pursue these type of careers that you hear us talking about up here today, because we need that what I call the pipeline. We need the young folks to start getting inspired more, to start doing the research and take over for those of us that are going to be, maybe towards the end of our careers. Because there could be very well folks out there that could really have significant breakthroughs by looking at the data that we get from Monday.
And we're going to pick up that outreach discussion when we bring up the second panel. But if we have one more question that we will answer very, very quickly. There's one way in the back there, down in the orchestra. Let's grab that person, and why don't you stand up? Somebody had a hand back there. Yeah, hi, sir. What's your question?
Hi. Why does the eclipse shadow move much faster over Oregon?
You know what?
than it does
I'm
here?
sorry. Could you give us that again? Because I think we missed it.
Why does the eclipse shadow move so much more quickly over Oregon than it does over Illinois?
All I heard was, why does the eclipse shadow move so quickly? Did you guys pick it up better?
Over Oregon.
Oh, over Oregon.
Yeah.
Because the sun hates Oregon. Everyone knows that.
Spoken like a
Next
Californian.
question. No, really. It's not moving any faster over Oregon, is it? I mean, the sun, really, of course, we're talking about the Earth rotating. Steve?
Well, and I'll look at my colleagues to correct me if I'm wrong, but you're right. It's based on orbital mechanics, as we call it. The Earth's rotation, the moon rotation around the Earth, and the sun's rotation. All of those three bodies moving together in concert really dictates the speed at which the shadow is going to be coming across the U.S. And I think I said earlier about an average of about 1,800 miles per hour, roughly.
Depending on your latitude, right?
Right,
Yeah.
right, exactly.
Okay.
And the total solar eclipses happen all over the world, and you know that you here at Carpendale, you will have another opportunity in 2024.
2024. That's why this is the
Right here.
crossroads of the eclipse crossroads. Yes. Go ahead, applaud your good fortune.
Yeah.
All right, we better finish off because we are so late getting first to Jenny Johnson, who's waiting to perform for us, but also to that great second panel. But we do have a treat for you, and Lucianne, we did say up front, you are an artist as well as a scientist. Not surprising. I have learned there are many, many scientists who live in that Venn diagram intersection of science and the arts. Tell us what we're about to hear.
So a couple of years ago, I did a piece of sound art, actually, about the Kepler mission. So one of the things that people don't necessarily realize, and Steve, you actually just mentioned this, is that stars rotate. And because they're plasma, so essentially more like gas than they are like solids, different latitudes of the star rotate at different speeds. And one of my past science projects was actually understanding the rotation of stars from looking at the Kepler data. And I started to think about how I could explore that data using sound instead of just graphs on a sheet of paper or a computer screen. So what you're hearing is the frequencies of those stars rotating, all played back over time. And you're hearing a number of different stars playing back, and it makes this sort of eerie music that you're hearing. And if you're not enjoying this, I promise the band will be a lot better than this. Seriously, I put this up in a gallery once, and somebody asked me if I could make it sound better. But the higher pitches that you hear are times when a star is rotating more quickly, and the lower pitches are more slower rotations. And you'll hear little drifts in the pitch as well, because one of the things that these bright and dark patches that we see on stars do is they reappear and dissipate at different latitudes. And because those different latitudes move at different speeds, you hear little bends in the pitch over time. And so, yeah.
I don't care what anybody says. I think it's lovely, and it gets better.
Thank you.
So you can find this. Is it online where anybody can hear it?
I guess the place to see it would be either on my webpage, which is tangledfields.com, or you can go to my SoundCloud page.
So very briefly, as we let this play under us, Steve, do you know offhand where people can learn more about what the Heliophysics division of NASA is up to?
Absolutely. You can go on nasa.gov, G-O-V website, and you can look at solar system and beyond. And there's a whole bunch of information there about this heliophysics, which is the study of the sun and its effects on the Earth and the other planets and bodies in our solar system.
Tom, any place that people should be looking for your work and what you're up to?
Well, at the University of Chicago, www.uchicago.edu.
And Nergis, how do we follow the budding appearance of gravitational astronomy and more research on gravitational waves?
Yeah, so LIGO.org, and our second observing run finishes on August 25th, and on that day we will put up an update on what we've seen from that run. So just in a couple more days.
We could keep going, but we have so much more to do. Please help me thank this absolutely outstanding panel. Thank you, folks. All right. As we play musical chairs, we're going to look over to stage right. Jenny, welcome. Is it true that this is going to be the first performance premiere of this new tune?
It is not true.
Darn. Well, just the same, it is delightful to have you. Ladies and gentlemen, welcome Southern Illinois' own Jenny Johnson Band.
Thank you so much. It's such a treat to be here. Thank you so much. I wrote this actually as part of my thesis exhibition last year, and I wrote it about how different cultures have perceived the solar eclipse over time. So before, essentially, science was involved, so people thought you would bang pots and pans and it would keep the demons away, and they told pregnant women not to go outside, those kinds of superstitions. And it's a little bit about how people perceive and celebrate the solar eclipse. And it is a call and response, so I'm going to ask you if you could repeat after me. Just on the chorus, it's really easy. So if I were to go, in the shadow, 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 in the shadow. Oh, that's wonderful. Do you want to be in my band? You sounded great. All right, so we're going to play this song, and real quick, I have Toby Merriman on fiddle, Nate Graham on bass, Kevin Olau on clarinet, and Al Pape on the accordion, and my name is Jenny Johnson. Sun and earth and moon align, keep shadow steals your fading light. Thank you very much.
The Jenny Johnson Band. I am Mat Kaplan from the Planetary Society here at Southern Illinois University, Carbondale, hours before the beginning of the Great American Eclipse. Planetary Radio Live continues now with 5 people who really want nothing more than to share their sense of what our boss, the science guy, calls the passion, beauty, and joy of what's going to be happening tomorrow. They see it as a rare opportunity for millions of Americans to be united under the shadow of the moon, and one hopes to keep that excitement about the cosmos alive for the rest of our lives. You remember those 2 gorgeous images that we opened with? They were both created by the next person that we're going to meet, the first person of this next panel. Kevin Moorfield has been a fellow Southern Californian, but one who's about to move his family to Oregon. In fact, they're in the process of making that move right now. Sorry about the sun joke. He also happens to be a proud Saluki. Kevin grew up looking through telescopes right here in Southern Illinois and dreamt of seeing a total eclipse. And now he's just one of the so-called eclipse chasers on this panel. He's going to see his 4th total solar eclipse tomorrow. Kevin has a remotely operated telescope in California for deep sky imaging, but he has done astrophotography from all over the world. And let's bring him out. Here is Kevin Moorfield. Okay, see this image on the cover of Sky and Telescope magazine? Yeah, that's one of his. Not bad.
Thank you.
You must have been, pull that right in close.
Right up here. Thank you very much.
Yeah, you must have been pretty proud.
Oh, yeah. I mean, this is a childhood dream. Are you kidding me? I had this magazine since I was 12.
Yeah, this is kind of, I mean, there's Astronomy magazine as well, also a great publication, but really for kind of professional and serious amateur astronomers, Sky and Telescope is pretty huge.
Yeah.
All right. We're going to take a look again at those other images of yours, but I want to get the rest of the folks out here. There are a lot of great people here at SIU that we need to thank for this really monumental eclipse celebration. But up at the top of that list, certainly nobody higher, is Bob Baer of the university's physics department. Some of you know him. Bob has been serving with Scott Ishman as co-chair of the Solar Eclipse Steering Committee, people responsible for all this. They've been working toward this day for something like 3 years. But this eclipse means even more to Bob because he is another eclipse chaser, and he's the Illinois coordinator of a project called Citizen CATE that we'll talk to him about in a few minutes. Please welcome Bob Baer. All right, so I admit it, everybody on this panel is an eclipse chaser at one level or another, including Michelle Nichols. Michelle has been with Chicago's Adler Planetarium for more than 20 years. She just got named that Great Science Resources Director of Public Observing. And she leads the Adler's many programs that open up the sky for all the rest of us. They include the Scopes in the City program. If you are in Saluki Stadium tomorrow, we mentioned that you'll see her everywhere as one of our primary correspondents throughout our 5-hour eclipse celebration. Please welcome Michelle Nichols. Nice job on the rehearsal today, Michelle. Pull that microphone right in close. Our next panelist is another NASA veteran. Lou Mayo of the Goddard Space Flight Center is a heliophysicist and planetary scientist who has been part of missions, including one you've heard about already, Cassini, that got that great backlit shot of Saturn, and Voyager, to many people the greatest planetary science mission of all time. His more than 20 years of program management experience include work on the Space Agency's National Space Science Data Center. For over 15 years, he has been creating and running a variety of space science education programs, working with Girl Scout leaders and Girl Scouts, and he supports about 150 after-school astronomy clubs worldwide. Lou serves as professor of astronomy at Marymount University in Arlington, Virginia, not far from Goddard, and he has been central to planning of SIU's Eclipse celebration. Please welcome Lou Mayo. So our last panelist. I was listening to National Public Radio a few mornings ago, and they aired this story about our collective excitement, not to say frenzy, about the Great American Eclipse. So I wasn't surprised when they shared our next guest's famous reaction to a total solar eclipse. You are in for a treat if you haven't heard it yet, but we're going to save it for the end of the show. Mike Kentrianakis is so much more than just an eclipse chaser. This former CBS News producer is no less than the eclipse project manager for the AAS, the American Astronomical Society. No group has had a bigger role in helping the U.S. prepare for what's coming tomorrow, all across the nation. He says he has waited his entire life for this eclipse, and he promises that it will change the lives of all who see it in totality. Please welcome Mike Kentrianakis. All right. I want to ask each of you right up front, at least all of you, and I think all of you have seen one of these before. Every eclipse chaser that I have talked to over the past, not just months, but years, has always used the same phrase to describe this: life-changing. Do you agree? Tell me your thoughts. Anybody can jump
Absolutely.
in. Let's start, Kevin.
I mean, it's an emotional experience. It's just something that you look up in the sky, you're seeing something that's not supposed to happen, but it's not dangerous. It's beautiful.
You promise, because there are a few people making these terrible predictions about signs and portents and what this is going to mean for us, as if we haven't had eclipses every few years for the history of our solar system. Bob.
That's nothing new.
Oh,
Lou, that's nothing new. Historically, we can go back thousands of years and see evidence that civilizations all over the world viewed solar eclipses as evil omens and bad signs and things to be afraid of. So, perhaps it's in our genes.
Anybody else want to get in on this? Was it life-changing? I know you told me it was life-changing, Michelle.
Yeah, so you instantly understand why people were terrified of these phenomena, because when you see totality, it looks like a hole in the sky. And I've used that phrase a lot, but words fail me often when I try to describe this, which is why I tell people that's why you need to go see this in person, because there's just nothing like it. There's no other astronomical phenomenon that really compares to this.
And in fact, here's a good shot of that hole in the sky. Kevin, that's one of yours, isn't it?
Yes.
Yeah.
Yeah, that's a good one of right in the middle of totality. Kind of brought out a little bit of the inner color. It's a little exaggerated, the color, just so you can see the loops.
Oh, there's a little Photoshop there?
Just
I hate
a little bit. It's real. It's just brought out.
Yeah, I'm okay with false color. That's fine. Tells us a lot. Get a lot of good science from false color. This one, this eclipse sequence, this is just gorgeous.
Yeah, well, I want to say it's the whole eclipse, but it's not. It's actually just the first half. This is the first 90 minutes. It looks exactly like this in reverse on the other side.
The same going in as it is going out. You got some of this. I don't know if it was either of these shots, but maybe, I don't know, both of them. When you were here, tell us about this place, which doesn't look at all like Carbondale.
No, this was...
Not right now, anyway.
This was Svalbard, about 800 miles from the North Pole in 2015. That's our family shot, because that was our family vacation. And, this is one of the things about once you see this, you know where your vacations are going to be for the next 20 years. You can just look at the list, and there you go.
And you're going to keep this up? I mean, tomorrow's not the last one for you?
Oh, absolutely.
Okay, we really are now going to go to the almost, not polar, but nearly polar opposite of Svalbard, and that's this shot Bob Baer, tell us where you are, or were.
Yeah, that's Tanjung Pandan, Indonesia. Halfway around the world, 13-hour time zone change from here.
And we got one of the shots that you got from there. You did get this there, didn't you?
That's the diamond ring. That's right at the end of totality. We missed the one at the start, but caught this one with our telescope.
Now, is the diamond ring something that if the skies are clear enough, we should expect to see, or is it iffy?
It's relatively bright. So that last bit of light coming around the moon, it's actually coming through the craters on the moon. And that forms like a starburst pattern, and it's relatively bright. So I think if we have any reasonably clear skies, we'll expect to see it.
You're in this next shot, too. It's almost the same shot, except it looks like it's nighttime. Did no one tell you the sun doesn't come out at night?
Right. So, and that's Sarah Kovac, SIU student, SIU physics major, and she's pointing at the diamond ring and yelling because I'm about to pull the filter off of the scope there. But that's how dark it gets, and it's just that quick.
And so I mean, we're going to get, what is it, Michelle? I think 2 minutes and 38 seconds of nighttime.
Exactly right. It's daytime turns to night, and it's an amazing sight.
And, you know, when you're out there, I know you're not going to want to take your eyes off the sun. I'm not going to want to. But, I mean, we're going to see it all around us because what happens down here on the surface will change. The way living things live will change because they're going to start to think it's nighttime, right?
Right. And one thing I have to clarify is people ask, how dark is it going to get? And I tell people about as dark as a full moon evening because the corona is about as bright as the full moon. And then the really weird thing is if you have a horizon view, you're going to see what looks like sunset all the way around the horizon, but the sun is up over your head. And so it's just an odd-looking sky.
Bob, I think this is your shot of the corona.
That's a composite that's put together. We talked about Photoshop a little bit, so I Photoshopped this one a tiny bit, but really, David Elmore is a member of the Citizen CATE team who put together, I think it's about 50 images, and did a special filtering method on this. And then my Photoshopping is to make the center of the moon look a little darker.
Okay. This next shot is one of yours, but it's from much closer to home. Tell us what's happening.
This is right outside of Nergis, and this is Citizen CATE experiment training going on with the volunteers. I think we have 2 teams in this shot, and both of these teams are taking data tomorrow. Actually, 68 teams across the country are taking data tomorrow with Citizen CATE experiment.
And what is Citizen CATE hoping to add to our knowledge of the sun?
Well, we're hoping to image the corona from coast to coast. And with 68 sites, you can actually get, hopefully, weather pending, continuous data. And that data will be shared with the scientific community eventually. I think it takes about a year for CATE to do the analysis themselves. But we look to get a little better understanding about that inner corona and then use that to finally come up with some, how do we want to put it, understand things like how the solar atmosphere, how the sun's atmosphere affects communications here on Earth is one practical application.
More of that solar weather concern and the inner corona that is so difficult to see, even when you have a telescope that has a so-called coronagraph, it really is not as effective as having the moon cross, right? Yeah.
It's not. When the moon blocks that sun, it blocks it out in space. So you get it blocked for you, and you don't have the sky glow going on, and you don't have this large disk blocking the sun. So you can see that corona right down to the surface of the sun.
Lou, I didn't give you any clue that we were going to do this, but isn't NASA working on some telescopes that are going to do a better job of sort of faking an eclipse?
Well, NASA puts a lot of effort into what we call heliophysics, the study of the sun, the solar atmosphere, its extent into the solar system, and then, of course, its effect on the planets. We have a very special mission that's going to launch next year. Well, it was called Solar Probe. Now it's called Parker Solar
Which
Probe.
we heard about some from Steve.
Yep.
You know, the one I was thinking of is a little farther down the line, even after the James Webb Space Telescope, is WFIRST that has a coronagraph, doesn't it?
That's right. That's right. Still won't get down to the photosphere of the sun, which is the interesting region we want to look at. That's the place where the temperature starts to reverse itself, and rather than getting lower as you move out from the sun, it starts to go up from about 6,000 degrees Kelvin on the surface of the sun, 4,500 degrees in the chromosphere, and then it rockets up to about 3 million degrees Kelvin. We don't know why, but these kinds of observations that we can make all the way down to the photosphere are going to help us figure it out.
Mike, Citizen CATE, great project, but it's only one of the citizen science projects underway. Are you familiar with any of the others? Really, you are, Bob?
As far as citizen science is concerned, I don't know many others, but I do know that scientists are observing the corona throughout the United States, in Oregon, in Idaho, Nebraska, mostly out west, and they're doing it on the ground. Dr. Shadi Habal, Dr. Jay Pasikoff, for instance, they're doing very heavy solar studies. This has been their specialty as heliophysicists, studying with eclipses. Because of the ability of the moon to perfectly obscure the sun right to the limb and getting that detail on the unscattered light, as Bob was saying, so we can look at the transition regions between photosphere, chromosphere to corona. So eclipses are a unique opportunity for study.
And we've got some slides coming up that belong to Lou he'll be able to tell us about. They talk about some of the NASA activity underway. Citizen CATE is largely citizens, right? Volunteers, people who are doing this for the love of it.
It is. All of the sites are operated by volunteers. There's a lead person for it. I think we have about 3 people on average for the site. So we're talking over 200 people just with the observing side of it. And we also have volunteers working the scientific side of it and developing the application that we use to collect data.
And one other citizen project that I know I've heard of is this one called the Mega Movie, the Eclipse Mega Movie. Do you know something about that?
Well, I'm familiar with it. The Mega Movie is similar in concept to CATE. I think the concept was original to the Mega Movie. And it is to image the corona in a similar way, but they're using non-standard equipment, whereas CATE has standardized equipment that we go through a pretty long period of training on. Mega Movie is, as I understand it, use what you have.
Yeah, even smartphones, I've
Yes.
heard. Right? Michelle, do you know something about this?
A little bit. So basically, if people were interested in taking some time and using their time during totality, before totality, after totality, to image the sun and use your DSLR, your camera phone, your whatever you've got. And so they're going to then put all those images and movies together to get, as you said, about an hour and a half, hopefully, of imagery all across the country.
And I'm going to stick with you for a moment, Michelle, because I want to talk about your previous eclipse experience. You also went to one of the far corners of our planet, but I don't think you faced the hardships that these guys did in Svalbard or Indonesia. Where were you?
So we were in 1999, August 11th, 1999. So a little over 18 years ago, we had a group of about 200 Adler Planetarium members, general public folks. We were across 2 cruise ships in the Black Sea. And so this was a picture taken from the Stella Solaris cruise ship, looking out toward the other 3 that were there. I was given 2 pieces of advice prior to this eclipse. It was, number 1, right before totality, take pictures off into the distance and get a sense of how dark it's actually getting, because your eyes are adjusting, and so you really don't truly get a sense of what it looks like. And so there's a few minutes later, we had drifted a little bit away from those other ships because our captain had turned the engines off, and so we were drifting. He didn't want the engine vibrations to shake people's telescopes and cameras. And then right before totality, so it really was that dark. And then the final picture is that one, and it says image credit me. I didn't take that picture, so I wish I would have. But no, I actually don't know who took it. I have to say unknown photographer, because this was a person, I think, who was on our ship. You know how you get off cruise ships and there's pictures there you can buy? That was one of them you could buy. So I have a picture of totality, because the other piece of advice I was given was put the cameras down. We didn't have camera phones at that time, but put all the equipment down. Stare at totality. Take those glasses off, the solar glasses off. Stare at totality and burn it into your brain, because your first time seeing this is like nothing else. And so I want people to consider doing that. Put the smartphones down, put the Facebook Live down, put all the Twitter, all of it, put it away and look up at the sky.
And we will encourage those of you in Saluki Stadium tomorrow to do exactly that. Now note that Michelle said, take the glasses off when totality has begun, because even a sliver of the sun is too much for your naked eye. You want to burn it into your brain, totality, not into your retinas.
Right.
Listen, the Adler Planetarium is a huge partner here at Carbondale, at SIU Carbondale, and not just here, but all over the Illinois region. What are some of the things that you and your colleagues are doing?
So this past week, we got down here on Monday. So the other team, we call it Galaxy Ride, and Galaxy Ride has been driving all across Southern Illinois to do programs for elementary schools, restaurants, bars, breweries, libraries. Where people are, that's where we went. And we've been doing activities related to the sun, moon, light, color, eclipses, and totally free. We just show up, and people have been showing up in the hundreds, and we could not be happier or more thankful to the folks down here in Southern Illinois for supporting us. And please, yes. And we also couldn't be more thankful to Southern Illinois University because they helped get the word out about all of this. So it's been just a win-win all around.
Take 30 seconds to give people a preview of what you and I and Jeff McGoy will be doing with lots of other people, 14,000 other people, in Saluki Stadium tomorrow.
So we're going to narrate the eclipse. We're going to give you all sorts of fun things to do during partial phases of the eclipse. You're going to have fun things to watch, like actual Saluki dogs on display there, so you can see them. And we have the band playing. We've got people who we're going to go into the crowd, ask questions of folks, have you ask questions of us, all sorts of things going on, and it's just going to be a blast. And I think those 5 hours are just going to go by like that. So
I got to see and pet Salukis for the first time yesterday, and boy, they are really beautiful dogs.
Yes,
They're
they are.
sweet, too. Lou, you've been at this for a long time. You're an astronomer. You're a scientist. I don't know that I've ever seen NASA encouraging and leading more public involvement in anything, including, the 7 minutes of terror, Curiosity going down to Mars. I'm not sure I've seen a public response like this since, well, at least the first shuttle launch and landing, or maybe even the Apollo 11 moon landing. I mean, what is the agency hoping to accomplish with all this?
Well, what we're hoping to accomplish is to bring the eclipse to people as only NASA can, kind of through the eyes of NASA. So there are a lot of wonderful and very effective education programs out there. AAS has some of them, SIU a lot at Adler. But NASA has spacecraft, and NASA has its most important asset, NASA scientists. So we're going to try to bring the eclipse to you, showing the eclipse from 14 NASA spacecraft.
And we've got a map that shows not just spacecraft activities, but things that are going to be happening on the ground, not just in the path of totality.
Right. We have a number of what we call official NASA sites all over the country. We have subject matter experts at each of these sites. Each of the sites has a safety plan, is ready to go, has resources that we've provided. So all of these sites along the path will be either broadcasting or webcasting or observing the eclipse. And so we're kind of gathering our forces right along, mostly along the path of totality, but not entirely.
I want to go back to citizen science projects because you've got some samples of some of the stuff that will be underway.
All right. So citizen science, the traditional definition here would be ways you can assist with science in a way that's publishable, new findings. And so we certainly have that for the public. We also have something we call citizen explorers, where you can do real science that's already been done. You can figure out the distance to the moon. You can calculate the speed of the umbral shadow across the Earth. Things like this that we already know, but you can actually do real science. And then we have a whole series of programs that are just kind of fun to do. We have art projects where you can...
There's some of those.
There you go, where you can predict you can draw the eclipse as you think it'll be, predict the way the corona is going to look. Eclipse in 6, where you just describe your experience of the eclipse in 6 words. It just rhymed, that's all. We thought would be cool. We have Dance Along the Path, this will be interesting. I can't wait to see what they send in for this. Record a dance in your community that describes your community or the eclipse experience you're having, and send it in to us, and we'll post it. So that's going to be, exciting. So a whole variety of things that people can do, eclipse selfies, and lots of ways to plug in, as we say, and really kind of own this experience as your own.
And we are proud that the main NASA webcast from NASA Edge is going to originate from right here, right next to Saluki Stadium. Tell us about NASA Edge and what they'll be doing.
Yeah, you bet, Matt. NASA Edge is an amazing group. They've been doing webcasts for, well over 2 decades. They're led by Chris Gersh and Blair Allen, who are just hilarious. They work together so well as co-hosts. And we've been all over the world with them. We've been to Turkey and China to broadcast eclipses. We've been to the summit at Mauna Kea at 14,000 feet, where we could barely breathe, much less think, and view the transit of Venus. We have been just to to launches of big space missions like Lunar Reconnaissance Orbiter and MAVEN. So NASA Edge is going to put on a 4.5-hour show right here at SIU, right outside the stadium. We're going to have scientist interviews. We're going to bring in images from space and from high-altitude balloons that we already talked about. And we have probably the best images of the sun, I think, that anyone's going to be able to take, because we've partnered with a group called Lunt Solar Systems. If you're amateur astronomers, you know Lunt Solar Systems. Then they have built what they call the Sun Lab. This is an amazing piece of technology. It's a 20-inch heliostat, 20-inch mirror.
Big.
That follows the sun, sends the light from the sun down an optical path, where we have 4 telescopes, hydrogen alpha and calcium K, which are tuned to look in the chromosphere, a white light telescope, which is perfect for seeing the corona, and then a color telescope that is going to see some of the chromosphere and the corona. And we are recording all of this in 6K. Right, so if you have a 4K TV, you think you're pretty hot. This is 6K. This has never been done before. And so these images are massive, and they have built a 24 CPU system to process these images, bringing out as much detail as possible. I've seen the preliminary images from them. It will just knock your socks off. So this will all be available. We're going to stream all of this live during our 4.5-hour webcast.
Kevin and Bob, time to play catch-up. 6K. You got to go to 8. You can't have enough K. And I'm not talking about Kelvin.
I don't know, 20 megapixels, that's what I'm shooting.
Okay, that sounds good enough to me. Mike, I teased people at the beginning of this segment about that video of yours, which has had, what, how many views now?
Well, it has 2.3 million on YouTube and 1.6 million on Facebook, and maybe a couple of million on other private sources that have downloaded it.
So what we're going to see is just a tiny piece of that video. They're going to see a somewhat longer segment in Saluki Stadium tomorrow. And the folks here at SIU Carbondale had some fun with this. And it is absolutely laughing with you because your enthusiasm is so infectious. But first, set this up. Tell us about this flight.
Well, I was called by a colleague, Joe Rayo, about the 2016 eclipse, and I was hesitant about going to Indonesia because of the heat and the difficulty to go out there at the time. And he said to me, Mike, if we're able to change the schedule of this single flight, Flight 870, on the day of the next total solar eclipse by 25 minutes, would you be interested in going on that flight? And I thought about it. It didn't actually take me long. I said, yes, absolutely. I said, that is great. We can actually have a news story where Americans can fly without a passport from Alaska from the 49th to the 50th state, whereas America's having this great American eclipse, so we can call it the almost great American eclipse. So that was my plan and thought. So yes, count me on, and let's do it. So it took a year of planning with Alaskan Airlines to change the schedule, post it as such, because it wasn't delayed as some people say it was. It was not delayed. It was 1 year ahead schedule, so they knew that everyone arrived on time. And there was a little hesitancy right toward the end where safety issues came up, as they always do. They just seem to come up. It's a nervous frenzy, safety, and we've had a legitimate one with this one, of course, as we all know about. But I called and interceded and spoke to the CEO, and I said, as the AAS, that this is what we do. We clear this with the safety. We wrote the flyer on this. We wrote the information, which we shared with NASA. So they felt more at ease that it was coming from the AAS, and then all of a sudden it was green-lighted. There were only really 12 of us who had booked the flights at regular airfare, and the rest of the passengers were unknowing that this was going to be an Eclipse flight. So we then Alaskan Airlines tipped off the media only days before, and as we were going to the gate, it was filled with media. There were so many cameras there, and I'm there with a coffee and a bagel saying, oh my God, you know, just going to the gate, what's going on here? And they're all, hi, can we interview you, this and that, and, you know, see this eclipse flight. It became a story just on itself. And we had met the pilots the night before for dinner, and they went over the plan, and it was so precisely drawn, and the times it had to leave at 2:15 precisely, wheels up, and their speed and their direction. We were worried about snow in Alaska delaying us and that they would have to plow the runway and we'd be late on it. And it left. I had my watch synchronized, and 2:15, wheels up. We just had a clearance like Air Force One or something. And I was like, we're going. They're going up there. So there we were flying. It was a few hours getting into it, and I didn't know what to expect because I've never had flown to see an eclipse. I heard stories, but I thought, being in a fuselage, it's enclosed, I'm just looking out a window.
Little tiny window, yeah.
Yeah, so it's like it's all contained. I'm like a little gerbil in here watching this eclipse. And so then it started getting darker. Like the eclipse was happening, we're using our solar filters and holding them up and saying, there it's happening, partial phases, which I'm very familiar with, having seen 20 solar eclipses, which is mostly partial phases. But then it started getting darker and darker, and all of a sudden, I could see the shadow of the moon directly in view of the eclipse, which is different normally on the ground where the shadow sweeps us from west to east. It will cross over us. And in the stadium, we'll have a little difficulty seeing it, but we will see it above us instead of from the ground. Whereas in this case, because we're at the end of the eclipse, we're looking directly into the shadow and have the eclipse there. So this shadow rose up above the horizon like a storm, like a tornado. I didn't know what to think. And it came, and it grew, and it grew, and it grew, and it just went into Bailey's beads, diamond ring, and totality. You could see the outline of the shadow perfectly on the cloud tops. It elongated there. Just because we were at the end, it becomes a real oval before it lifted up and went into outer space and left us until tomorrow.
Okay. But as Al Jolson said, you ain't seen nothing yet. We're going to watch that. We're going to watch one tiny piece of that video with Mike, and hopefully the audio is up because you're going to want to hear this.
Look at that curved shadow. Look at that. Look at it come in the light. Oh my God. Passing right in the shadow of the moon. Look at that. So look at those prominences. You can see them with your naked eye. This chromosphere. Look at that. Here comes the shadow. It's lifting up. It's going out. It's going out. Going up to the atmosphere. Oh, look at down there. Light. Oh, what is it? It's beating. It's oh, that's a flare. Look at that diamond ring. Look at that. Oh my God. Diamond ring. Oh, look at that. Oh my God. Wow. Oh my God. Look at that. Wow. Oh. Ooh, yeah.
Bravo.
Yeah.
And Matt,
Kevin, go ahead.
What usually follows 21 oh my gods, by the way, is it was so short.
Which is why you got to do it again, right,
Yeah,
Michelle?
Yeah, the rule of thumb is, the phrase that you hear often from people who've seen these is, every total solar eclipse lasts 8 seconds, because that's what it feels like. It may last 2 minutes and 38 seconds here, but it's going to feel like 8 seconds.
The question I've been wanting to ask you, Mike, ever since I first saw that, didn't the plane start to tilt because everybody went over to that side?
People were laughing in the plane, from me. It was quite contagious. It is funny. I mean, when I watched it myself, I've actually laughed at it, thinking, who is this nut? He's an absolute nut, because it happens. And tomorrow I'll be vindicated. Yeah, the long time.
So one thing that, when I first watched that video, I watched the whole thing, and I started crying again, because the first time I saw totality, I sobbed. I absolutely sobbed. And I still don't exactly know why. But I'm wondering tomorrow, I don't know what I'm going to feel, but I had the same chills, and I just started crying, sitting there at my desk at work. So I had to like clean myself up, make sure nobody was watching me. So, but no, that was incredible.
I don't know about you folks, but this only makes me even more excited looking forward to tomorrow. We're going to go to your opportunity, those of you here in Shryock Auditorium at Southern Illinois University, Carbondale, to throw a few very limited number of questions at our
there they are.
excellent panelists. There you are now. We can see you. You stayed. Thank you. We've got those microphones that are going to be floating around in the aisle, and there's somebody right down here, fairly close to that side. When we finish this question, raise your hand again, and we'll see if we can get to you. Hi, ma'am.
Hi. It's so exciting to have you and the former panel come to my alma mater. As a scientist and someone who was fortunate to see Bucky Fuller talk here, and we celebrate him here, I'm very concerned with the current climate. The personal is political. I'm concerned about people's perceptions of science, and future funding of space expeditions and research, and just wanted kind of your comments on that.
Lou, can you tackle that?
Yeah, I can say a few things about that. Well, Congresses come and go, and administrations come and go, and NASA's budget is generally pretty steady, rising a little bit. I forget the exact number, about $20 billion. I was talking to Steve Clarke yesterday, who's the head of Heliophysics at NASA headquarters, and he's out at the White House now for a year on the Office of Science and Technology Committee. Steve was saying that they're very interested in space weather. Fantastic. Space weather, this is the kind of the foundation of heliophysics. We know we have a strong planetary program. We have a number of launches. I know some of you know that it's kind of sad that we're going to kill Cassini on September 15th. It'll take its last images and dive into the atmosphere of Saturn. But we have James Webb Space Telescope launching next year, which has yeah, you can applaud for that, sure.
You bet.
It's been a long time. Long time coming. This is an amazing telescope that's going to let us see almost to the beginning.
We like to say at the Planetary Society that we live in the golden age of exploration of our solar system and beyond. But it is a never-ending battle to maintain the ability of the world's greatest space agency to continue to do the work it does. And not just the agency, but all the other scientists and people involved with space science, space exploration, and really all of science. It is something that all of us as citizens have to remain aware of. Michelle?
I just wanted to say that that's one of the major goals of the Adler Planetarium, is to make sure that we all know science is for everyone. And so that's why we welcome everyone to come and join us in that endeavor called science, because we do it every day. And so we want to make sure that everybody is welcome to join us in that quest.
Hear, hear. Let's go to another question. We'll try and get in a couple more of these, either from up here or up in the balcony. There is somebody way down in the front here. Hi, sir. Okay, first of all, nice shirt. He's got a Planetary Society shirt on.
Thank you. There's been a lot of discussion about hoping to use all of the excitement about the eclipse to have more interest in space science, solar science. How can we keep capitalizing on this, especially given we have one coming in 2024? How can we keep the enthusiasm going?
Yeah, because we know we're inspiring or exciting millions of people across North America, maybe even hundreds of millions. But that is the trick, isn't it? We want to reawaken that sense of wonder, that passion, beauty, and joy of science that all of us had when we were 2 years old. I know all of you are involved with this effort. Bob?
I think it's already happening. People are so excited about this with the talks that have been going on around Southern Illinois for the last few years. I've just seen so many people excited about this and just happy to have some good news, I dare say, about an eclipse coming. And I think we're going to see that tomorrow with the 14,000 people in the stadium witnessing this together. I'm really excited to hear what they have to say after this.
Mike, I want to go to you because obviously the AAS doesn't want this to be a flash in the pan. They want ongoing interest in space science and astronomy.
And there is. For any amateur astronomer or scientist knows there is so much happening in the sky, and there's so much as far as NASA is concerned and other agencies doing exploration. So I would put it with an analogy that even though tomorrow might be the best movie that comes out in this year, we still go to movies after that, don't we? I mean, we don't just say, that's it, we're done. So there's lots to see and learn and take from each and every event. So there'll be more, and there'll be more eclipses, and who knows what else.
Kevin, when you take your pictures, when you do your astrophotography, are you thinking about hoping that this is the kind of thing that's going to interest more people in this love that you have?
Oh, absolutely. I mean, if you can get a picture out there that a million people see, which I got once, I mean, that was really exciting because I know that it's something that a lot of people are interacting with and enjoying the science part of it and the beauty of it.
So I'll let you in on a secret. We knew that we were going to go till at least 7 o'clock, but we're now pushing beyond 7 because we still have the What's Up competition, and hopefully that phone call to Bruce Betts coming up, who joins me at the end of every episode of Planetary Radio. So hope you can stick around. You might win yourself a rubber asteroid, as we say, and maybe that Celestron solar telescope. But let's take one more question. I don't know if we've got anybody way up there on the balcony. Is somebody? Seats. You deserve to get one answered up there again, folks. Hi.
Hi. I've heard that the moon is slowly distancing itself from the Earth. So after a while, you won't get to see these. Like totality won't exist anymore. Is that true?
This actually came up with the first panel. It is very true. And as a corollary, the moon used to be much closer to the Earth, right, Michelle?
So we have a perfectly sized moon for the distance that it is from the sun. So our moon is 400 times smaller than the sun, but the sun is 400 times farther away. But as you said, the moon is slowly receding from the Earth, about 1.5 inches a year, maybe about as fast as your fingernails grow. And so in about 600 million years, no more,
give or take,
no more total solar eclipses on Earth. So we are living in the right age plus another few 100 million years to be able to see this and enjoy it.
We're going to quit there for the audience Q&A, but Bob, I want to come back to you because of what's happening tomorrow, and I believe we have a little overhead shot of SIU Carbondale. Tell us what to expect on the day of the Great American Eclipse, at least here in Carbondale.
Well, we've got a lot going on still in a lot of different areas. So the Art and Craft Fair is still going on. The Expo at the Arena is still going on tomorrow.
We have a very excited young person in the audience who doesn't want to see it end.
It's ready. Eclipse Day in Saluki Stadium, that's our big event. And right outside of that, at that #1 location, is the NASA Edge Megacast for the day. There's several stages over in that area now. So as people walk through, they'll notice this is a big deal for the area, for the entire region. And finally, the carnival going on in that #4 location just south of the arena. That'll be going on through tomorrow evening as well.
All right, with that, we will need to say goodbye to these great folks who have and are working so hard to make sure that all of us, at least here in town, and there are many like them across the country, will get the most enjoyment and fascination out of the Great American Eclipse. So please thank our outreach and citizen science panel very much. And with that, I will let you folks exit. Are you just pushing it out of the way, or did you want to say something? Okay, Lou's done. Go ahead, guys. Thank you. Terrific job. I'm going to see if I can. Once again, you get to look behind the scenes here. Whoop, you know what? Before I do that, because there really is no internet in this building, bear with me for a moment or two here. Again, the radio audience won't get to see any of this. But I'm going to turn on the personal hotspot on my phone. And if you're doing Facebook Live right now, consider stopping. Because there really is not enough bandwidth to be able to pull this off. I think I will actually pull my microphone off. I've got to get back on the Wi-Fi. There we are. We're connecting. We are connected. Let's see if we can reach Bruce Betts, the Director of Science and Technology for the Planetary Society, as we call his cell phone. Everybody writing down the phone number right now? Bruce.
Bruce.
Hello, Bruce. Can you hear me? Oh, it's a bad connection. Say hi to us. Bruce, can you hear me?
Yes. Can you hear me?
Oh, it's breaking up quite a bit. Are you using a speakerphone or? We actually had a much better connection. You know what? I'm going to try calling you back. I don't know if you can hear that, but I'm hanging up on you. I'm going to try again. Let's give that one more shot. Otherwise, we will go to Plan B, and we will still have the contest. We just won't have Bruce to help us conduct it.
Hello.
That's a little better, I think. Hey, Bruce, welcome. We're listening to you here at Shryock Auditorium at Southern Illinois University, Carbondale.
Excellent. Did you clarify the reason?
Boy, this is not a great connection. Can you understand him? Nah. Hey, Bruce, nice try.
Yeah.
Thank you so much. Ladies and gentlemen, the Director of Science and Technology for the Planetary Society. Hey, Bruce, thanks for trying. I'll talk to you in a few days. Okay, he's gone. All right, with that, because he only just sent me the questions that we're going to be dealing with, I'm going to go to my mail and pull those up, because it is Bruce, as those of you know who listen to Planetary Radio regularly, who comes up with the questions, and normally we throw those out to the audience, and then we throw out the prizes as well. So here they are. All right, I'm going to stand up to do this. And because I have a lousy arm compared to Bruce, I'm going to ask you, if you are one of the winners, just come on up.